Okay, let's try and work on, we'll just give the general theme of the quantum numbers. And I can ask you a variety of questions about this, but they may range from something like, okay, I have an electron in a 3s orbital. What are the quantum numbers for that electron, one electron in a 3s orbital? So you're going to want to know what 3 means and what s means. And those refer to quantum numbers. The other way to think about this is that we're going to go the other way, that we have quantum numbers n, we have quantum numbers L, we have quantum number m sub L, and we have quantum number m sub s. Now, every electron that is in an atom is assigned a set of these quantum numbers, and they cannot be the same for any atom in the same, any electron in the same atom. So I have my nucleus, and then remember, n is equal to 1, n is equal to 2, n is equal to 3, and so on. And in an n equal to 1 shell, there can only be an s orbital. And then every time we go out a shell, we add a type of orbital. So then in n is equal to 2, yeah, there's always going to be that s we've already added, and now there's a p added to that. And then there's always the same as we go out, so s and p, but now we add d to that. And as we continue out, 4, n is equal to 4 has f's, and so on. And then you're going to remember how many of each type there are. So there are only ever one type of s orbital, but when we get to p, there are 3 p orbitals every time there is one p orbital. And then d, there are 5 p orbitals, and those all have their origin in the quantum numbers. So that's where we have to start our understanding to really be able to use these with some ability or freedom. So n, remember, is about physical size, how far away from the nucleus on average an electron is, and those can take on values of starting at 1, going up to infinity with integer steps. So it could be 709, it could be 837, it could be more likely 7 or 8. It represents the shell in which the electron resides. And then what is possible in each of those shells is what are dictated by the other quantum numbers. So L is about angular momentum, and it takes on the value of whatever the value of n is. So it's going to be n minus 1 down to however many values you can have before it gets to 0. So for example, I'll down here use my examples. So when n is equal to 1, s can be equal to, well, n minus 1, which is 1 minus 1. That's equal to 0, down to 0. So there's only 0. That's the only possibility when n is equal to 1 for L. And that's why there's only one s orbital in the first shell. And there is only one s orbital total.